So this video is to help you go over a couple of practice problems on simplifying trigonometric functions. We're going to start on page 14. We're going to go down the page and do these 5 problems. So problem number 5 says that I have cosecant squared of theta minus 1. And I just simplify it. Anytime you have a trig function squared, I would recommend looking at your Pythagorean identities, especially when there's no 1 in the expression. So if we go look at our Pythagorean identities, we have one that says 1 plus cotangent squared theta equals cosecant squared theta. And I can manipulate this by minusing the 1 over. So cotangent squared equals cosecant squared theta minus 1, which is what I have right here. So this expression that I have in white is equivalent to cotangent squared theta. Let's try another one. Number 6 says that I have 1 minus sine x times 1 plus sine x. We're going to FOIL, we're going to distribute, we're going to do the first, outsides, insides, last. So we're going to get 1 minus a sine x plus a sine x minus a sine squared x, because sine times sine is sine squared. These two in the middle are going to cancel each other out. So now I have 1 minus, oh, hang on, I did not mean to change the color. So I have 1 minus sine squared x. And just like on the previous problem, anytime I have a trig function squared with a plus or minus 1, I want to go think of my Pythagorean identities. I have one that says sine squared x plus cosine squared x equals 1. By minusing the sine squared over on both sides, you get that cosine squared x is equivalent to 1 minus sine squared x. So this thing that I had right here that I'm circling is equivalent to cosine squared x. And that's your answer. Let's try another one. Number 7 says I have sine squared theta times cosecant squared theta minus 1. If you remember back to the first problem I did, number 5, we proved that this thing right here was equivalent to cotangent squared theta. So I'm going to write sine squared theta times cotangent squared theta. I'm going to rewrite my cotangent squared. Cotangent we know is the same thing as x over y, which is my cosine squared theta over my sine squared theta. My original sine squared is like sine squared over 1, and then these sines are going to cross off. So I'm left with cosine squared over 1, which is just a cosine squared theta. Number 8. Cosine theta times a tangent theta times a it's supposed to be an S, times a cosecant theta. Well, nothing's squared here, so your best bet when everything else fails is to go back to your roots, go back to your sines and cosines. So this is a cosine theta times, sine is y over x, so my sine theta over cosine theta, cosine was over 1, times, this is the same thing as 1 over sine theta because they're reciprocals. So my cosine and my cosine will cancel out, and my sine will cancel out. So this is the same thing as 1. I love these that just come out to 1. Number 9 says that I have cosecant theta times over 1 plus cotangent squared theta. I want to look at just this bottom part for a second because it's definitely a trigonometric Pythagorean identity. So I know that 1 plus cotangent squared theta is equal to cosecant squared theta. So I'm going to replace it. So on top I have my cosecant theta, And on bottom, I have a cosecant squared theta. Well, that's the same thing as cosecant theta on top over a cosecant theta times another, times another cosecant theta. Well, I can cross off one cosecant from the top and one from the bottom, so I'm left with 1 over cosecant theta. Cosecant is the same thing as sine, so I have 1 over sine. So we can flip the bottom and multiply, so we get 1 times sine theta over 1, which is just a sine theta. Oh, number 10 in the fractions. We got this, guys. So I'm going to have 1 over sine squared theta minus 1 over tangent squared theta. So 1 over sine is cosecant. So 1 over sine squared is going to be a cosecant squared theta. Minus 1 over tangent is cotangent. So 1 over tangent squared is a cotangent squared theta. And this is a Pythagorean identity in disguise. Because we have a Pythagorean identity that says 1 plus cotangent squared theta equals cosecant squared theta. So I'm going to subtract this cotangent squared over to the other side. And you're going to get that 1 equals cosecant squared theta minus cotangent squared theta. So this whole thing right here is equal to 1. Not so bad. See, fractions are okay. Last one, number 11. I have a sine squared x plus sine squared x times a cotangent squared x. Both pieces have a sine squared in them, so I'm going to factor out. I'm going to have a sine squared x. There's a 1 left in the first part plus a cotangent squared x. This piece right here is a Pythagorean identity. 1 plus cotangent is equal to cosecant squared theta. And I still have my sine right here. Sorry, I did not mean to change that x. It should have stayed an x. These are multiplied. So I have sine squared x over 1 times 1 over sine squared x. These sine squared x's are going to cancel out, and we got 1 again. So hopefully that was some good practice for you.